Okay, this is a video to review graphing piecewise functions. A piecewise function is a function that is defined by several parts of other functions. For example, we could have x squared negative 1, 2. 1 minus x for x is greater than 2, and cube root of x for x is less than or equal to negative 1. So we have 3 pieces here, and I'll attempt to do 3 colors if I can find 3 that'll show up. First of all, let's just take a look at this function over here. We should be able to evaluate various x values of this function without graphing it. For example, if I wanted to know what f of 2 was, I would basically need to look in each of the x restrictions to see where 2 fits. So 2 fits in the second piece because it's equal to 2, so that would be 2 squared, and that would be 4. If I wanted to know what f of 3 was, I would look up here. I see that it fits into this piece, so I would plug it into this piece. And lastly, if I gave a number like negative 8, that's less than negative 1, so that would fit into the first piece. So we can do that without even graphing the function. But let's graph the function, and then we can check our answers here and make sure it matches on our graph. So if we look at the first piece, this is the cube root of x, and this has a shape like this. But I only want it for less than or equal to negative 1. So basically what I'm going to do is I'm going to plug in negative 1 into the function to find out where my starting point is. When x equals negative 1, y is the cube root of negative 1, which is negative 1. So I come over here and I put a closed circle on negative 1. Now I want the rest of the cubed root, but I want it to the left of negative 1 because I want it to be less than. So I'll just plot one more point on cubed root, which is negative 8, negative 2, and then I'll go ahead and put an arrow because it's going forever less than negative 1. The next piece is x squared, which looks like a parabola. I have a starting point and an ending point that I want to plug in. When I plug in negative 1, I get 1. And when I plug in 2, I get 4. So this would be an open circle, and this would be a closed circle. Now I might be tempted to just connect the dots. However, we know that x squared hits 0 and comes back up. So this is a piece of x squared. If you think about x squared, it would be this whole thing. We're cutting it off between negative 1 and 2. Lastly, we have this function, 1 minus x. I'll plug in 2 for x, and I will get negative 1. So I'm plotting this point with an open circle. And then I'm not sure which direction this goes. I know that is for x is greater than 2. So x is greater than 2 is going to be from here over. So I need to determine whether the line is going to go up or down or maybe straight across. If you're not familiar with slope or you're uncomfortable with it, the best thing to do is to pick an x value bigger than 2, say 3, and substitute it in. So if I did 1 minus 3, I would get negative 2. So that gives me another point on the line, 3, negative 2, which tells me that the line has a negative slope, which I knew from looking at the equation because it's 1 minus x, therefore the slope is negative 1. So let's just do a quick check of our values that we evaluated before we graph this. If I look at my graph, does f of 2 equal 4? Yes, because it's a closed circle. If I look at my graph, does f of 3 equal negative 2? No. So I must have messed that up. F of 3, oh yes it does. Right here, f of 3 equals negative 2. Scratch that. If f of negative 8 equals negative 2, yes, right here. And that's how you graph a piecewise function.